Welcome to our lesson of physics practical, and today we are in experiment number 5. If you are not ready for experiment number 1 up to experiment number 4, subscribe our channel Skills Learning Network for excellence knowledge, and you will see those uploaded experiments and other knowledges found within our channel. We have physics practical, we have chemistry practical, we have even biology lessons within practicals, theories, and other concepts. So for today, experiment number 5, we are going to determine the electromotive force of a cell and the internal resistance of a cell using ammeter and a voltmeter. That is our aim of the experiment. And the difference here from experiment number 2, number 3, number 4 is the nature of the graphs and the type of the questions within that experiment. The important thing when you perform experiment or physics practical, you have to know the theory of the experiment after performing the procedure, after recording the data. That is very important for the students or expert who is performing the experiment. Consider our experimental results, experimental circuit. That is our circuit. We have a voltmeter, we have ammeter, we have a cell, we have rheostat, and we have the switch. That is our circuit of our experiment. And then let's proceed with the procedure for this experiment. The first procedure is connect the circuit as shown in a figure or in that our circuit with the key open. Make sure the key is open. Even if it is not closed or closed your readings, it means the voltmeter is parallel with a cell. It means your voltmeter is going to read the voltage or the voltage of the cell. Yes. So with the key is open, read and record the voltmeter reading, and then close the key and adjust the rheostat so that the cell supplies a small current through the circuit. Then after closing the key, record this current and the new reading of the voltmeter or the volt on voltmeter. Keep the key closed and adjust the rheostat so that slightly larger current flows through the circuit. Then after performing that, again record the value of current and the potential difference. Repeat that procedure above to obtain a set of 5 pairs of readings, and record readings of current and the voltmeter or voltage difference or potential difference, each time slightly adjusting the rheostat so to increase the current. That is our procedure. Then after performing that procedure, what are the questions according to our experiment? Question number 1, plot a graph of V against the I, potential difference against the current. Question number 2, find the slope of the graph. Number 3, deduce or calculate the value of E.M.F and the internal resistance of a cell. That is a cell, not a battery. Of a cell. That is our questions. You have to understand how to solve it, what is the nature of the graph, what will be the value of E.M.F and the internal resistance of a cell. After performing that, we can see the table results. I have performed this experiment. That is my data. you can see how is recorded. The voltmeter readings of potential difference is that one, and the ammeter readings is that one. The first data, before closing the key, our voltage was 1.5, was 1.5 readings, volt 1.5 volt. After closing the key and the reading and adjusting the rheostat, our readings is see at the in that table: 1 to 1.1, 1.3, 0.3, 1.4, 0.2, 1.5, 0.1. That is our data of our experiment. Then after that, you have to plot a graph to see the nature of the graph. Let's proceed with the theory of our experiment. Theory our experiment. General equation is that one: E.M.F is equal to current bracket resistance plus internal resistance. Our graph is equal to V against I. So you have to find the nature of the graph correlating with the graph V against current. From that general equation, E.M.F is that bracket current R plus R. So remove bracket, E.M.F is equal to current times resistance plus current times internal resistance. In order to get the V, we have to use from the Ohm's law, but IR is equal to V. And then instead of putting this one, we put V. V is equal to E.M.F minus IR. It means we want to be V is equal to Y axis and the current should be X axis. So in order to have a correct graph, our question is this one: V is equal to negative IR plus E.M.F. And when you see that nature, our graph is correct or is correlated with this question. Y is equal to V, X is equal to I, and C is equal to E.M.F, and our slope is equal to negative IR. When you see your data is inversely proportional to each other, that means when this increase, the current is decrease, and our circuit, the voltage is parallel with the cell. So we cannot expect to use the Ohm's law when you say V is equal to IR. It means when V increase, resistance increase. No, it's not necessary, because our circuit voltmeter is parallel with a cell, so is inversely proportional. So the nature of our graph is this one: it shows slope which is negative. So that is our nature of the graph. You can see that is the nature of our graph. It's going to be negative slope. Y is equal to Y axis is equal to V, and the X axis is equal to current. So from the equation of the graph, M is equal to slope, which is equal to negative R, and the C is equal to Y intercept, and is equal to E.M.F, which is E. Therefore, how to solve this E.M.F and the internal resistance? The slope is equal to change in V over change in I. So let's proceed with how to deduce, how to calculate E.M.F and the internal resistance of a cell. For E.M.F, we calculate from the Y-intercept. From this equation, Y-intercept, which is equal to V, is equal to E.M.F. So we are going to substitute to make a substitution. So we are going to read the intercept of Y from the graph. this is the intercept of y, or intercept of y is equal to E.M.F. So in order to get the E.M.F, we are going to consider intercept of y axis. So y is equal to y intercept is equal to E.M.F. So y is going to put the value of E.M.F. For internal resistance, we have seen that our slope is negative, so the slope will be negative. So we are going to make substitution of slope is equal to negative r. So negative slope is equal to negative r. We divide by negative, it means negative will cancel and they will remain with the value of r. So r is obtained from slope and the E.M.F obtained from y intercept. That is our solution to solve that practical experiment number 5. And our nature of the graph was V against I. So the physical meaning of y-intercept is equal to electromotive force, and the physical meaning of the slope represents the value of internal resistance. And the general, I'm sure when we are going to perform really practical by plotting the graph, by solving, the E.M.F of the cell is equal to 1.5 and the slope would be 0.5. That is our experiment number 5. Subscribe our channel. Let's give us a comment. We will upload another experiment which is very important to you to understand more about physics. Share this knowledge, like, allow notification for the coming lesson. Thank you for learning with me.